Hi all, welcome back for my next video series in Golang programming. In today's topic, we are going to discuss and understand about pointers in Golang. This we are using tutorials point to go through what is mentioned as part of pointers. In other tutorials, it is not available. So if you want, you come to tutorials point and go through the programming language for your understanding. So those who are familiar with C, C++, and those who are with Java people, right? They would have learned C and they would have understood regarding the pointers. C people, no doubt, people who are familiar with C, C++, they will work on in and out of C language pointers, C or C++ pointers, and there is a major disadvantage where you will have to allocate, deallocate, and do the memory management, which is a pain. And when I was working in C, C++ programs development, we don't reference a memory and then start accessing, then programs start crashing. And we create memory, we allocate memory, and then if we don't deallocate, if continue to run the program for a longer period, then memory will creep on, and then at one point of time memory crash will happen. So this is a major task for day-to-day C, C++ developers to ensure that memory management is properly handled and managed. Because of that, some complexities, other languages such as Java has evolved. um, um, I think Go language also evolved, um, uh, considering this pointer memory management is a measure. So there is a dynamic memory management enabled in Golang, so we don't have to worry about the memory management. But let us actually ensure that pointers are handled very well and in a right way. So so Go programming tasks are performed more easily with pointers, and other tasks such as call by reference so cannot be performed without pointers. So call by reference, that means there is a memory, and a memory has an address, and then we actually you know uh, access that particular memory through the memory address or reference. Okay, so as you know, a variable is a memory location, and every memory location has its address defined, which can be accessed using the m percentage operator, address operator. This is a m percentage operator or address operator, which denotes an address of the address in the memory. Consider the following example, which will print the address. So each variable will have an address. Okay, address in the memory, right? So if you see, variable is declared in a so memory is like a um, a let us take two columns. One is memory address and second column is values. Okay, so let us, I think, describe in this open. Open calc. Okay, so meanwhile, let it open. So here, if we give that m percentage address operator, so what will happen is, this is the address. in the memory. Memory is like a map, a reference and then a value, a reference and a value. So whenever you declare a variable, it reserves that particular memory, and then whenever we are actually working on it, that particular value will be stored in that memory. Okay, so that is how you can think about. Okay, so now if it is open, right, let us explain in Excel sheet. Okay, so let us take, this is the memory I want to declare. Okay, right. So memory will be referenced with the hexadecimal number, but memory 1, memory 2, memory 3, memory 4, memory 5, memory 6, like that, and values are kept here. For example, 20, 30, 40. So whenever you declare a variable name refers to address of 1 with the value of 20. Okay, A is a variable name, B is another variable name, C is another variable name, D is another variable name. Okay, E, like that. So F. Okay, these are the variable names, and these are the addresses. Address will be larger as we have seen in earlier, and then this is a variable name, and this is address, and this is value. Okay, so this is how in the memory it will do the memory management scope to that particular program. Okay, so what are the pointers? A pointer is a variable whose value is the address of another variable. So that means, see, a variable name is this one, right? So now pointer is, for example, pointer 1, what it will have. For example, I want to reference, then it is address, not the value. For example, pointer 1 of B is address here, and then okay, so a pointer is a variable whose value is the address of another variable. Okay, let us actually, this one is a 6, actually this is the 7th address, and then its value is 2. You should not add you can do the manipulation. If you increase the address, no, then it is pointing to 3, like that. So, and the value of pointer 1 is, which is actually address of 2, that means variable of B, and its value is 39. Okay, so that is how it is. We will discuss that. Okay, direct address of the memory, like any variable, you just declare a pointer before you can use it. Store the address of the variable. So a variable, you can declare variable name and a star, right, and the type. So what is the type of the variable? Okay, so it is only a declaration where IP star int, where FP star float. Okay, it is only a declaration of a pointer. Currently it doesn't have any address. Okay, there are few important points which are frequently performed. We defined pointer variables, right? That is what we have actually discussed earlier. We define a pointer variable and assign the address of the variable to a pointer. So as I mentioned, right, we define int star, that means like this, pointer, variable name pointer and star int, and then that is the declaration, right, define. Then we are assigning the address of the variable, that means we are actually adding the address. You see, this is the a is int I equal 20, for example. This is what we have declared. Okay, this the value is 20. Okay, and then ip star int, we have only declared here variable declaration, and then now we are assigning the address of a. What is the address of a? Okay, let us take a. Okay, what is the address of a is 1. Okay, address of a is 1. Ampersand as a means we are storing the address of a 1. Now if you print ampersand of a, what will happen? If you print ampersand of a, do you think it will print 1? No, the value which is inside this 1 will be printed, that is 20. Okay, and then sorry, we are actually printing the address, that means address will be printed. Address means 7 will be printed, and then value inside. Okay, ip. Okay, let us actually I think let us not do that one. So what happens, you see here, ampersand of a. Okay, address of the variable, that is address of the variable of a. Address of the variable of a is 1, that will be printed. Okay, and then ip, that means address stored in ip, that is value of ip, that is 1 will be printed. You see, both are same, 1 will be printed. And then if you use the star ip, then what happens is star pointer 1, that means the value inside 1 will be printed. Okay, it is pointing from, here the value, the address which is stored here, and it goes to address and then value inside that. So that is how the pointer value will be printed. So hope you understand. If you want me to explain, I will explain. Okay, a is the, I will explain through this again. A is the variable we declared. Yeah, let us actually remove all this. A is a variable which has address of 11111. Let us take 1000, 10,000. Okay, and then what happened? We declared variable, then we declared a pointer, but it doesn't have any value. Now we assigned a value here. We assigned ampersand of a. Ampersand means address assigned to the IP. Now we are printing ampersand of a means address of a. Address of a means what? That is 10,000. Okay, and then we are printing IP. What is the value allocated to that? We allocated address of a, right? That means again the value inside IP is 10,000, right? Okay, so 10,000 is printed here, and then now we are actually using the accessing of a pointer, that means star IP. Star IP means what is the value of IP, and that is 10,000. What is value stored in 10,000? That is 20. That value will be printed. Okay, so that is how you need to understand about the pointers. Okay, so hope you understand. So if you have any doubt, again reference, go through this. So go compile assigns nil value to a pointer variable in case you do not have an exact address to be assigned. Nil. So remember this, you can compare if it is, you always need to check a value nil pointer or not, then you need to work on it, otherwise it will always go into the issues and errors. So you can check a pointer not equal to nil or pointer equal to nil. Okay, if not equal to nil only, then you have to start displaying or working on the code. For example, here what you can do, if IP not equal to nil, right, then only you want to access this okay, then only you want to access. Okay, so it will execute as it is. Oh, what did we keep here? Okay, so compilation errors you can resolve it. Okay, so now what happened is IP not equal to nil, then only we are accepting. Okay, so for example, if we have not assigned any value, you see we have not assigned any address, so ampersand is 0 and then IP is a nil parameter, right, as added, then IP not equal to nil, then so it has this has failed, this condition has failed and the value has not printed. Okay, so this is how you can actually work on the pointers. So it is a pointers. So we will also discuss array pointers and pointer to a pointer and pointer passing. Okay, let us see if this is there. Let us not go to that one. Let us see. Go array of pointers. If we have that, let us actually go into that. Okay. So what we discussed is, this is an array of int with values 10, 20. That means 3 values, and then we are actually declaring, we are accessing, a equal to 10, b equal to a0 is 1, a0 is 10, a1 is 100, index a2 is 200, right? So now let us actually declare max is 3 and then we are declaring the ptr. Okay, then we are allocating values. Okay, let us actually, we are allocating values and we are accessing through the pointers. Okay, let us see this one. Let us check this program. Okay, so we have declared a constant with the integer and 3, and then we declared an integer with the 3 values, and then now, okay, this is a simple array declaration, right? We are just printing the array values. Let us actually execute this one. It will just print the array values, right? We know, we have already learned this. Okay, now this one is not coming, so let us copy paste this. Let us copy paste this and okay, so let us execute this. You see what happened? We actually allocated address of a into the pointer ptr, and then we are referencing. Okay, we are referencing, right? Or you want me to explain? I will explain again. So we have declared max as a constant with 3, and then we declared an array of a with integer data type, and we are allocating 3 values, 10, 100 and 200, and we declared index variable as a integer I, and then we declared pointers. You see, pointer and maximum of 3 integer pointers we declared, and then this one we are allocating the pointers with the address of a, and then we are again indexing from 0 to 3, and then we are printing percentage d address of a of 0. Actually we are printing ptr but pointing to that address, right? So we are actually getting the same value, 10, 100, 200. Hope you understand. If not, go through this and then repeatedly practice it. So what I want to uh, describe about is a pointer to a pointer. You can also do a pointer to a pointer. That means a pointer is an address, a pointer is an address, and then a value, right? For example, IP1, okay, this address is 10,001, okay, and this address is 10,002, and this value is address of IP. Okay, so it is like this. Is fun to understand the concept, but we will create double pointer star star int, where pointer star star into. So this is IP1, this is IP, and this is a. Okay, if you reference here, this is IP1. IP1 contains the address of IP 10,001, and 10,001 consists of address of a variable which is 10,000, and then 10,000 has value of 20. Okay, then once you allocate the addresses, you can reference the corresponding star star, and it will actually display the value of 1000. So let us see. So this is the integer variable a, and this is the pointer variable ptr, and this is a pointer to the pointer, and we are assigning a equal to 3, and pointer is assigned with the ampersand of a, that means address of a, and pointer to the pointer is assigned with the address of pointer. Now if you print a, it will print same 3000. If you print star ptr, then it will print again a value, and then star star ptr, it will print again 3000, but addresses are different. So this is how you will access the pointers to the pointer. Okay, so let us go back. Okay, so we have thoroughly gone through the pointers. Hope you all followed. If you don't follow, repeatedly see this and go through this tutorials point. It is explained very well. And if you like this video, um, like, share and subscribe, and for upcoming